students. In this lecture we are going to discuss about second point about aliphatic nucleophilic substitution reaction. In last lecture we discussed about SN1 reaction, and in this lecture we are going to discuss about SN2 reaction, that is nucleophilic substitution bimolecular reaction. So in case of this, take one example, that is alkaline hydrolysis of methyl bromide. Alkaline hydrolysis of methyl bromide. Okay, so first take a methyl bromide in presence of OH minus, that is our base, as we are doing alkaline hydrolysis, right? So product will be this. Br is a leaving group and OH is a nucleophile. This is our substrate. This is our substrate molecule. This one is a nucleophile. So nucleophilic attack will take place on this substrate and you will get a product, that is CH3OH. Means this nucleophile is going to substitute this Br minus, and eliminating group will be, means leaving group will be Br minus. This one is a leaving group, right? So this is a SN2 type of reaction. Just see its mechanism. SN2 type of reaction is single step reaction. It is a single step reaction. And SN2 and SN1 reaction was two-step reaction. In SN1, what we discussed, that first step is the formation of carbocation, and in second step that carbocation get attacked by nucleophile and product formation takes place. But in case of SN2, it is a single step reaction, means attack of nucleophile and departure of leaving group takes place within a same step. See, we have this OH minus as an attacking nucleophile and our substrate is CH3Br, that is methyl bromide. Now as this OH minus is going to attack from the backward side and this leaving group is eliminated from front side, so both attack as well as departure taking place within a same step. So formation of transition state takes place. You will get formation of new bond between this carbon and OH and elimination of breaking of this Br and carbon bond at the same time within a transition state, remaining as it is CH3, right? So this is a transition state. There was no such a state formation in SN1 reaction because there was a two-step reaction. First one was formation of carbocation and second was attack of nucleophile. But in case of this SN2 reaction, attack of nucleophile and departure of this leaving group, means elimination of this leaving group taking place in a same state. Next condition will be after. So here you can see, here is a Br containing delta minus charge. Its electronegativity is more than carbon. Also this OH also containing delta minus charge, and on this carbon there will be partial delta plus charge. So attack means making a bond and breaking of this bond. Making of this bond means OH and carbon bond, and breaking of this bond taking place within the same time. Okay, so next will be breaking of this bond and formation of firm bond of this OH and carbon. You will get OH CH3, right? And leaving group will be Br minus. Now this is a substitution product. Now you can see in this reaction the nucleophile attack and the substrate form from the just opposite side, means nucleophilic attack on the substrate and the leaving group. The substrate, the nucleophile attack on the substrate from the opposite side of the leaving group, right? So it will give you inversion of configuration, that is from the back side opposite, that is 180 degree. म्हणजे हा जो लिव्हिंग ग्रुप इथनं डिपार्ट होतोय त्याच्याबरोबर 180 डिग्री पासून काय होतं, न्यूक्लियोफाइल अटॅक करतोय. सो इट गिव यू टोटली inversion of configuration. In case of SN1 reaction, there was not such a case. There was a formation of carbocation takes place and nucleophile may be attacked from back side or from the front side. So there was a racemization is possible. But in this case, as a nucleophile is only attacking from the back side, there is only inversion of configuration will takes place, right? In case of kinetics of this reaction, see, in case of SN1 reaction, what we discussed that at the rate of SN1 reaction last lecture, SN1 reaction, the rate was directly proportional to concentration of substrate, right? But in case of this SN2 reaction, we are going to see that as this is a slow step where the transition state formation takes place. So in case of this nucleophilic attack and departure of this means substrate as well as nucleophile, this one is a nucleophile, right? Nucleophile as well as substrate both are taking part in the reaction where there is a transition state formation takes place, means slow step. So both nucleophile as well as substrate, means concentration of nucleophile as well as concentration of substrate is important, means taking part in the reaction for the transition state formation. So you can say rate of this reaction is directly proportional to concentration of substrate as well as concentration of nucleophile. Okay. So by the study means rate law will say it will be a second order reaction. It will be a second order reaction. In case of SN1 reaction, what said that that was a first order reaction. In case of SN2 reaction, it is a second order reaction. Why? Because rate is directly proportional to concentration of substrate as well as concentration of nucleophile. But in some cases, by experiment, it suggested that the rate of SN2 reaction also sometimes it will follow that the rate is directly proportional to concentration of substrate only. In such a condition, it will show you first order reaction. So by just saying two molecules, means both molecules, substrate as well as nucleophile, taking part in the reaction, you can't say it is a second order reaction. You can just say it is a bimolecular reaction. It is a bimolecular reaction. Okay. So SN2 reaction, the rate is directly proportional to concentration of substrate as well as concentration of nucleophile. That's why we say it is a nucleophilic substitution bimolecular reaction. Okay. Then in case of a stereochemistry of SN2 reaction, in last lecture we studied that in case of SN1 reaction, stereochemistry will be changed, means it may give you after racemization, inversion of configuration as well as retention of configuration. Racemic mixture formation was possible. But in case of SN2 reaction, stereochemistry. Let's see about stereochemistry of SN2 reaction. Okay, so main concept of SN2 reaction is nucleophile will attack from backside of the substrate and from front side leaving group will be depart out. So as the nucleophile will attack from backside, there is always inversion of configuration takes place. Inversion of configuration will takes place. Okay, suppose we have this ethanol, pH ClH Me. We have this reaction, and suppose we have this with 100% R configuration. Okay, so after reaction you will get, what will be the possibility? This ethoxide ion will attack from the back side on this carbon and Cl- will be eliminated out, right? So now this R configuration will be totally changes to S configuration. So ethoxide Me, hydrogen remains as it is, and as it is taking from the back side of this carbon, this pH group will come at this side pH. So it will be 100% S configuration. Firstly it was R and totally it is changes to S. So it is a total inversion of configuration. In case of SN2 mechanism, inversion of configuration takes place. But in case was SN1 mechanism, there was possibility of racemization. And in case of SN2, that is totally inversion of configuration takes place. Okay. Now in case of formation of substituted product, if there is a carbocation formation takes place, like in case of SN1 reaction, we discussed that first step was formation of carbocation. So as the formation of carbocation takes place, that carbocation will try to become more stable, and as there is a more stability, more resonating structure will be there, and each resonating structure may give its different product. So more different products or more substituted product will be there. But in case of this SN2 reaction, there is no formation of carbocation, only one step reaction. So it will give you only one product with the inversion of configuration. So no side product or no no side product will be possible in SN2 reaction. In case of substitution, last point was substitution at bridgehead carbon atom. So suppose we have one example like this. Suppose we have this example. This structure is 1-bromo 3,3 dimethyl bicyclo. Let me write 1-bromo 3,3 dimethyl bicyclo. Just you can continue from this bicyclo. Then in case of bicyclic compound, you have to write the number in bracket 2, 2, 2 and octane. How many carbon atom? That is octane. It is 1-bromo. You have to start from the bridgehead carbon atom 1, 2, 3, 4, 5, 6. Likewise this. So here for the substitution, you can start from least number comes at the substitution. So 1, 2, 3. So it is 3. So at 3 position it is dimethyl group. So 3, 3. 1-bromo 3,3 dimethyl bicyclo. And how many carbon atoms? Okay, octane. 1, 2, 3, 4, 5, 6 and 7, 8. 8 carbon atoms is there, so it is octane. And each breach containing how many carbon atoms? 1, 2, 1, 2 and 1, 2. So it is 2, 2, 2 octane. Okay. So it is 1-bromo 3,3 dimethyl bicyclo 2, 2, 2 octane. Now in case of this, if there is a SN2 reaction, we have to do. Suppose we have ethoxide molecule. Then in case of this, SN2 reaction is not possible. Why? Because in case of SN2 reaction, backside attack was there. But in this case, there is cage-like structure is formed. So backside attack is not possible. As this cage-like structure, the backside attack is not possible. So in general, the nucleophilic reaction is not possible. जर longer side chain असेल किंवा large group असेल तर it may be possible. But just in normal condition at bridgehead carbon atom, nucleophilic substitution by molecular reaction is not possible. Okay. So this is about SN2 reaction. There are some example about this. I have given you notes about that. There are 4 problems. So you can go through that. And if you have any question, then you can ask me. Thank you.